have you here.
Yeah, thank you very much, and thanks for the opportunity. Hi, my name is Jacob Kokubili. So without any further ado, let me just dive into the topic for today. I'll be sharing my screen. Let me know if you can see my screen. Can anyone hear me?
Yeah, we can. I can see your screen.
Okay, I just wanted to confirm. Yeah. So welcome to this session about data pipelines. Like she already mentioned, my name is Jacob Ukubili. I've been working as a data engineer stroke analyst for almost like 4 years. I transferred from civil engineering about 4 years ago and found myself in data analytics, then engineering. I currently work with two startups. One is a prop tech startup, and that one is an e-commerce startup based in the UK. So that's pretty much about me. So we are looking at data pipeline. Data pipeline, it's very much the same as every other pipeline that you know. Let's take the oil and gas industry, for instance. You have the upstream and downstream. So the upstream is more like saying, oh, you are going to the offshore or onshore to extract those crude oil, like in the raw form. Then you transport those crude oil to maybe like a tank or a tank farm or a processing plant for a storage, where you now refine those products into kerosene, petrol, diesel, and whatnot. Then the end products you now push to the end users, which is the downstream sector, who will now sell to different customers. So the same thing applicable to data pipelines, literally. So it's moving data from a source system to the final destination, and it involves different processes. So there are many definitions, and these were just a few ones I could get. There are many definitions what data pipeline truly means. So for instance, data pipeline is a series of tasks such as transformation, filters, aggregation, merging, and what have you. So literally it means you extract data or pull data from the source system or systems. It all depends on how many data and where the sources are you're trying to extract the data from. Then you transform that data, first of all, by cleaning, removing duplicates, change data types to make sure like the data are in the right formats. Then also doing a bit of aggregations, maybe like trying to get quantity times sale price or the average sales price over time. So you do the aggregations during the course of the transformation. Then also filter. Maybe you want to filter by country, say sales over time for Nigeria. You do that. Then you now load to the final destination, which is the the storage, maybe the data warehouse or a flat file or a data lake. It all depends on the desired outcome or what the stakeholders actually want. So that's pretty much what data pipeline is. It's very just exporting data from one point to the other. And during this point of point of transportation, there's also some things that needs to be done, like cleaning the data, transforming the data, aggregating it, filtering the data, and making data ready for analytical purposes or machine learning purposes. It all depends on whatever you want to use data for. So this data source itself is like the upstream, while the end users, people who are using the data, maybe like the data analysts, machine learning engineer, and BI analysts. So they are the end users. That's the downstream users of the entire data pipeline. Now, what are the important benefits of data pipeline? It helps us move data easily from one source to the other. And this data, by the process of building that data pipeline, you're also making sure that the data is accurate and is available for the end user, because you have to do some check to make sure the data is clean, is in the right state, the right data type, and it's complete. There are no known values, there are no missing values. We'll look at those later, much later. Then it also play a crucial role in real-time analytics and decision making. We'll also look at this when we talk about type of data pipelines. We'll talk about the batch processing and the stream processing. Then it automates workflows, reducing manual efforts and improving efficiency. So by this, it means that ideally you would just write maybe a Google Sheets scripts to extract data and create another tab, do transformation there, and do another transformation there, then take it to a final location. Or you just extract data manually, clean, then create another script again to load and what have you. But with data pipeline, you're able to automate with a lot of orchestration tools, which we would also look at much later. Then it enables the organization to extract valuable insight from their data, leading to better business strategies. So when you're able to move this data from the source to the final destination, the data is already ready for the end users, that's the downstream users, to now explore, dig or dive into or discover business insights that will be valuable to the organization. So these are just the few importance and benefits of, running a data pipeline. Then components of data pipe. Now, we are very conversant with ETL process or ELT processes. These are components of a data pipeline, and I believe most of us already know what ETL stands for or what ELT stands for. Came in recently, not too long ago. It's just an upgraded ETL process. So ETL actually means extract, transform, load, while ELT means extract, load, transform. So I would explain. Now, extract means to pull data or extract data or bring data from somewhere. And where is that somewhere? Which we could ideally refer to as source, in the data ecosystem. The source system. This system could vary from API, databases, data lake, flat files like Excel, CSV, and whatnot. It could be in different formats. You understand? So you extract this data then to a staging area. And mind you, from the process of extracting the data and transforming data, there's a bit of storage where that data would rest, first of all, before you transform. So most times it's either in a system, it's persisted somewhere along the line where you're able to transform those data. Now, the transform part is the T, which is transformation, which I have mentioned before, which actually entails you trying to make sure that this data does not have duplicates. The data types are right. There are no missing values. And if there are missing values, should you keep the missing values? Maybe there are just one or two things that are missing. Or could you feed these missing values, or could you drop them and stuff like that? So then, what are the business cases you're trying to solve in terms of this transforming data? Mind you that this entire, ETL process is tied to a business requirement. It could mean that your stakeholders wants to know the cost of a particular product in the last 5 years. For you to be able to get that information, that's the business case they are requesting. Then you need to go to the source system that has this information, because the source system does not give you the exact, the exact business requirements they're asking for. So it means you have to go back and get that information from different files or systems, wherever they are stored. Maybe sales is stored in one table in database. There's an API tracking shipping costs. So it could just be different locations. So you bring that data, you transform them. So the aim of transformation is for you to be able to answer that business questions, which means you're trying to get the total cost price for this particular products. So by joining the table, aggregating the values, featuring, and all of those things, then you now load that final transformation to the data warehouse or database, as the case may be, which will now be used by the end users. Now, let's talk about the load part of the ETL process. So now the data has been transformed, it is ready for the end users. Then we would now move this data that is complete to the data warehouse or database or a flat file or data lake. It all depends on what the infrastructure you are using, the data infrastructure you are using. Now, if you look at this part of the slide, you see analytics. This could be the data analyst trying to create a dashboard for the stakeholders to see, maybe sales over time and what's not, and also try to explore the data further. So this is just a summary of the ETL process in general. Then talking about ELT. ELT is just the same, just like you're moving the T forward and bringing the L to the middle. So in the case of extracting and transforming and loading data, you would load the data first, and now transform the data in the data warehouse. So this is commonly found with data warehouses especially for big data. When you're trying to analyze historical data, you get. So yeah, please, if you have any question, you could just maybe ask along the way. Then, so this is what a typical a data pipe. So you see there are different, the export parts, you have different source systems. So you have the CRM and other platforms. So you have the transform, you have the ALT, it's data warehouse, like I've mentioned. Now, type of data pipelines. I mentioned batch processing and stream processing. So as the names implies, it actually means that for the batch processing, you just take data. They're both streaming anyways in some school of thought. They're both streaming. but just that one comes in batches, which is scheduled maybe hourly, maybe in minutes, maybe daily, maybe monthly, maybe yearly. It comes in chunks. You don't just load it at once. It comes in chunks. So you'd take a bit, maybe like 100 rows, transform, install, transform and insert in your data warehouse. Then you have the streaming and processing, which is like, people say it's real time. Some say it's near real time, but I'll say it's near real time because there's also some latency, means there's a bit of delay. You understand? So it streams data from the source. It could be from IoT devices, it could be from other data warehouses, it could be from maybe live events. So you just stream those data, transform it along the line, and dump in data warehouse. So that's just the difference between the stream processing and the batch processing. So there's a bit of I wrote out a code for just these parts. I'll just try to try and summarize, so I don't waste too much time. So I can run you through the code. Just to show you the batch processing. Then the data architecture. So ideally, there's something called data pipeline architecture. So it's more of a visual representation of the entire data. What's it called? A pipeline. The components, the different components of data pipeline. That could be where it's coming, the source where it's coming from, where it's going to. It's just like the different channels with the pass before you get to the final destination from this source to the target location. So you see it for a typical architecture diagram. You see different components, different infrastructures being displayed just to enlighten both the people designing the data architecture, people implementing the design and all of those, including the stakeholders, just to have an overview of what the infrastructure or data pipeline actually looks like. So it will mean maybe having like Netflix API, pulling data from Netflix API, pulling data from maybe from WHO websites, maybe uploading CSV files, just showing those different components. Then maybe data, maybe using like Microsoft SSIS for integration for data transformation, and also using that to load the data into SQL Server database and stuff like that, basically. Then maybe Airflow to orchestrate, this whole entire process of manually running all the different parts or components of the data pipeline. You just automate it and to run like that. Then also that of data governance, observability, or monitoring or logging, where you'd also, put in consideration security measures that also guaranteeing data integrity, quality assurance, and also logging to or monitoring data, the entire data pipeline to manage resources, to know the processing time for each components, of the data pipeline. That being said, we'll now look at what makes a good data pipeline. What are the qualities of a good data? Please ignore this error here. I'll just in hurry. When I was on this slide, my bad, apologies. What makes a good data pipeline, or what's the qualities of a great data pipeline? One, it has to be resilient. Resiliency means this data pipeline can handle errors. Because most times when you even write your code, there will probably be errors. Can handle errors and still work functionally, without breaking down during the course of transporting data from the source to rest. Then automating retries. So it means while there is error or the pipeline is failing, maybe extracting the data pipeline, transforming or loading, it will retry a couple of times. So it has to be resilient, it has to be strong, it has to be firm. So after that, it would now, tries. And if it tries and is able to, pick up from where it's maybe resolving the errors, then it will now, go to the next phase. Then also talk about independency, which is literally running the data pipeline multiple times and also getting the same results at the same time. It's maybe something happened along your data pipeline and there was maybe something happened and it broke down. It will not lose any data. It will not lose data along the line. It would get data, it will pick up from where it stops. So each time you run data, it will still give you the same results without losing any data. It's more like it will always give you the exact results that the expected data or expected outcome of the data pipeline. Also talk about scalability and scalability. Scalability literally means the system is a system, whether software or hardware, capable of or subject to change whenever there is a need for it within a data pipeline. By that I mean, if for instance you have, say, you have a data warehouse that can maybe store data of say 1,000 or 1 million records, and your sales has grown exponentially. If that data warehouse does not have the capacity to, to expand, it will not be able to accommodate that those additional volume of data that are coming. So it has to be scalable. It means it can increase and it can decrease. It all depends on on the volume of data. And this also depends on two factors. So there is vertical scalability, which means scaling out. So it means adding like nodes or clusters to your machine, maybe like Kubernetes or using like a distributed system like PySpark. You get, so it expands horizontally, means it's scaling out, it's going sideways. You get. Then also talk about vertical scalability, which means scaling up. This one is just more like, say for instance now, so for the horizontal scalability, it could also be for data warehouse like BigQuery, maybe Amazon Redshift, Snowflake. Those are like very common use cases. Even Databricks, PySpark. So those are common use cases of horizontal scalability. They scale out horizontally. Then talking about the vertical or scalability, which scales up. So this is more like, maybe like your EC2 instance or your this instance in AWS. So maybe you have like, you already built your extract and transform function and load function, So that's process. If the volume of data has increased sometimes, you would also need more power to, to process those information. So it means adding, maybe like increasing from HDD to SSD, or adding more, CPUs to it, basically. And also, improving speed, basically. Then also talk about transparency. It means like documenting your work, make it readable. There are no black box during transformation. Someone who wasn't there when you designed the entire architecture or the entire infrastructure will come and actually implement or make adjustments. It also means it has to be flexible. So you have to document every process from start to finish on how you implement the data pipeline. Now, we'll also look at some best practices when it comes to building a data pipeline. I've mentioned some before, but I'll just reiterate. So we talk about modular design. You must have heard something called dry. Do not repeat yourself when it comes to coding. So it literally means don't repeat yourself. So if there's some things you can do like run concurrently, why not do it of writing A and repeat again? So the best practice is to do or implement modular designs, which means breaking the data pipeline into small reusable models to make it easy to test, to understand and to maintain, basically. So it's actually advised that we don't repeat ourselves while coding. Then automating of data pipeline, like I mentioned, it's just a process of orchestrating the entire workflow. Workflow means like data moving from the point of extraction to the point of transformation and to the point of loading data to the data warehouse. That could be done maybe by like scheduling the entire workflow orchestration jobs so that it runs maybe daily, maybe hourly, maybe weekly, maybe monthly. And some tools that you would use for these are like Airflow, Prefect, Merge, and a few other ones, basically. Then also talk about looking at monitoring and logging. So monitoring and logging is just to keep track of data pipeline in terms of performance. That would also mean trying to track the data processing time, how long it takes for the entire data pipeline to run, or the different components of the data pipeline to run, data volume, resource utilization, and whatnot. So in a nutshell, monitoring and logging can help you improve the overall quality of your data pipeline, by just trying to, and it also gives room for, or it also makes it easy for you to troubleshoot when you are having issues with the data pipeline. Then talk about data governance. Data governance is like a framework management, to ensure that the data pipeline is meeting business and regulatory requirements. So like data quality, ensuring that policies and procedures, for data quality, security, compliance are met. So it does help us ensure that the data flow from our data pipeline has high data quality or is of high quality and meets compliance and the business requirements. Then scalability, what I just mentioned, it's actually a very strong part of. I'll say it's the major part of your data pipeline entire process. So it's more like saying if you are building a house, and the house doesn't have a strong foundation, and expect this house to last for like 100 years, it doesn't have a strong foundation, the house will not last. Maybe it won't reach the midlife of the house, it could collapse. You get? It's like you. Okay, let me give you an example with say for instance, you have like a 4-story building and you have a water tank or a water tank on the say midway to the fourth floor. You get? And if you notice the pressure of that water coming to your house, into your rooms, your toilet and your wash hand basin, the pressure will be very low until you now get something like a pressure pump, which will now increase the volume of the water entering the house. The same thing with scalability. So you have to have that at the back of your mind when you're building the entire data pipeline. So when you say best practices, these are things you should bear at the back of your mind whenever you're building a data pipeline. You understand? So they should be at the back of your mind. They are very important and they would help you a lot. They also talk about talking about what's it called? Scalability. I just want to add a few things. So there's three V's. So I'll say 5 V's, but I just like sticking to 3 V's, which means velocity, which means volume, and which means variety. Velocity means speed. I mentioned something similar to that. It means speed, of a data for that point of, movement. So talk about speed, which is velocity. Talk about volume, the size of the data. The size will increase eventually for every growing business to increase. So you need to factor all these things in: velocity, volume. Then the other one is variety, which means they're coming from different sources, different data formats. They can be in different formats. It can be in JSON, can be in Pocket, can be in Excel, can be in CSV. Just name the formats. It can be from different source. You understand? Can be HTML, URL link, and all of those things. So these are the things you have to bear in mind when it comes to scalability. They also talk about version control, which I know most of us are very familiar with Git, GitHub, GitLab, and all those. So those are just they are used to try just track code changes, review them, before they are pushed to pushed to production. So they help you track codes. If there are changes, you improve. And sometimes they use CI/CD. From trying to integrate continuous integration and continuous development or deployment. Trying to integrate the codes from the different CI/CD platform and all of those things. So it's also encourage collaborations amongst data engineers or analytics engineers. So data engineering in nutshell, or data pipelines in nutshell, is like designing a software. So all these are those components of what an ideal software best practice should entails. So we'll also look at data lineage. So it's literally just the documentation of data's journey from the point of extraction to the point when the data is loaded. So it's increased trust. So it means you could see how data is moving, from different data models. Because during the course of building your data pipelines, you'd also build data models, which I believe we are already aware of. It all depends on data models you're building. So it also show those lineage of how like a data flow, you understand. Then ensuring a data pipeline works as expected. So there are a few things you could do to make sure it works as expected. One is unit testing. So unit testing usually just means testing the code, that was used to build the pipelines. So you literally just testing all those functions, functions you had used to, write the code to make sure they are okay, they are correct. Then there's also this end-to-end testing, which is more like, peer review. No, I won't say it's not peer review per se. It's testing the entire data pipeline from end to end. I'm trying to remember there's also a party that is for that to test the data pipeline end to end. Then code review is run the code by your colleagues. Maybe after writing the code, before you push to production, someone has to review, approve that, make sure that the code is correct. So what you're putting to production is not the wrong thing, and it's correct. It has data quality and integrity, basically. Then in production, so the one I just said is before production. This is what you need to do before you push to production. Then in production, you also need to do logging in. Logging in is also it's more like getting information of the different stages data has passed, the error it has what's it called? It has recorded during the course of running that pipeline for that particular time frame. Number of records that was inserted into the data warehouse or put into the data warehouse or the data lake. It all depends on the target system. So it does give informations of how long it took for the data pipeline to run. Then also alerting. So alerting is more like saying when there's failure, maybe it's trying to retry, when there's failure, it's trying to retry. So it sends a notification to you that, oh, something is actually wrong with your data pipeline. And you then now see what is wrong with data pipeline, why it's not functioning well. Then also the issue of communication. You also need to communicate with the end users or the stakeholders involved, in the project, like data pipeline, especially with the business requirements, and just to make sure that what is expected is what you're producing. Then the final stage is checking the storage. So this one is actually very important. It's not just about moving data, transforming it, but also making sure that the data that is going to the target system, it's correct, it's complete, there are no missing values, the total number of records, what is expected from the course of transformation is the same thing that you have in production, like the final destination in production. Yeah, so that is just a summary of data pipeline. I will just allow for a few questions before I run you through a code, a typical data pipeline Python script. Questions? Can you guys hear me?
Yes, we can hear you.
Questions? Okay. Questions.
Everyone is just quiet. Thank you
Hi,
so
everyone.
much, Jacob, for the
Yeah,
training.
I have a question.
Okay, sorry.
This
Go ahead.
okay. I've been hearing of Microsoft Fabric. How does
Sorry, your line
this relate with Microsoft Fabric?
none of this. It's like it's muffled. You can just send it. You can send a chat instead if you can't hear me. So I'll just go through the chats.
Hello, please, can you hear me? Hello.
I can hear you, Tochukwu. I don't know
Yeah,
if
we
Jacob
can.
is here. Okay.
Okay.
Hi, Jacob.
Okay. I just have a personal question. Maybe probably as kind of to understand like how the bigger picture works. Okay, let's assume I want to like maybe do a personal project that involves maybe real-time analysis with data set that you can kind of be uploading like kind of continuously. And let's say I'm just familiar with just maybe a single programming language, for example, Python.
Okay.
So just to like kind of understand maybe if I want to build a web app or something that involves all this process, like how maybe can I go about it? Like just being familiar with just Python alone.
Okay, I'm trying to let me get your question right so that I can relate it to Jacob when he comes back online. You want to build like a real-time streaming pipeline, but you want a web app that the web app, is it going to be taking the results of the pipeline or be supplying the data for the pipeline? Because I believe a web app is like, I don't know, like a website or something, or an app I understand that web app part. So what is the web app going to be and what kind of data are we looking at? The pipeline, the real-time pipeline is, I won't say it's a separate conversation from the app itself, although they feed each other. So are you saying that what you're going to be getting from the app will be feeding the pipeline, or the result of the pipeline will be feeding the app, or it will be like a round trip.
Okay, let's say for example, maybe a particular section of the app could contain where you can upload new data, just like
Okay.
upload it and then you now get the results.
Results in like
Mhm.
results.
Like it will analyze the data and then give you the outputs and maybe some visualizations too.
Yeah, but is that going to be riding on real time? Because if we are looking at if it's that one is just I'm trying to explain it well to you. If we are giving new data for the system to do some processing and then give you results, the processing part, is it like if it's going
Okay.
to be riding on machine learning, then it's going to be historical. It's going to be riding on a model to give you results. But if maybe the system itself is to be giving you like real-time information, I think that would be around like software development. But let me hear what Jacob has to say. Because if
Okay.
me, I'm trying to understand what you're saying. As data,
Sorry. Okay.
yeah, Jacob. So Tochuku had a question and he was saying that
Okay.
in terms of pipeline, like real-time pipeline, if he wants to like build like a web app that takes in new data and gives the results immediately, how would that relate to a real-time pipeline? So I'm trying to see what angle is coming from, because if it's coming from the aspect of ML, machine learning, relating to
Yeah.
data pipelining, it won't really be real time. The result is real time. The architecture of the software will be real time, yes. But in terms of the data, it will use historical data, which is, I mean, like the model, the ML machine, if it's going to be like a form of prediction or something, it should be
Yeah.
historical. But if it's that it's streaming data from somewhere to show dashboard real, like for example, when I did a real-time pipeline project, it was streaming directly from a transactional DB. So as customers were making transactions on real time, the dashboard was adjusting itself. You get, like, I didn't need to wait 2 hours or 3 hours for a dashboard to update. It updates immediately. That's a use case. You get. So I'm trying to see which one he's talking about.
Okay. I guess I should be coming from the machine learning aspect with this. Yeah,
Okay.
it should be from the machine learning aspect.
The machine learning aspect is that you built a model. The model
Yeah.
is in production. So what you want to do is that on real time, when a customer sends maybe a new data, it gives you like a real time prediction, right?
Yeah.
Yeah. Okay. Maybe Jacob could answer that. I want to
Okay.
get his point of view. Yeah.
Okay. Yeah. Sorry, they changed my lights from Gen to NEPA, and my internet went off. So, apologies. Yeah. So I'll just add a few things to what Fit has said. Let's use Uber, for example. We're very conversant with Uber, for example. So if I want to say I want to make a trip to say from Lekki to say Obalende, for instance. They already have the ML, they already have like historical data sets that has been trained. You get, so whatever Uber is giving at that point in time, it's not like I would say it's a near real-time experience. It's real-time in the real sense, but it's a near real-time experience because what it's giving you is based on historical data, but it's streaming that data and telling you the exact how much it will cost from Lekki to Obalende. I don't know if that makes sense. I'm just trying to give you another example of what Faith is trying to say, because she already makes mention of transactional and the dashboard. So there's this school of thought that says, oh, there's real time and there's near real time. But if you look at it in a real sense, it's actually no real time because there's also a bit of latency. You get, may that be microseconds or milliseconds, basically. I don't know if that answers the question.
Okay, so Tochiko, let me just add this. That's real-time thing. So that real-time thing, it will not be relying on the model itself, in the sense that when you build the model, like the way we built model before, but I don't think we touched on model deployment. You're going to deploy on a cloud platform, like an Azure. Now, when you deploy on Azure, Azure allows you to either get the will I call it the endpoints. They will give you two types of endpoints: batch
Like
endpoint
an
and
API.
real-time endpoints. Yes. So if you want it to be working real time, you pick the real time endpoint. So hopefully we can get someone that is into ML ops to explain that part to you. You get. So if you pick a real time endpoint, when you write, maybe you build your web app using Flask. So that's the whole Python, using Python throughout thing. So if you build it using Flask or is it Django now? Is it Django they call it? Yeah,
Django, yeah.
yeah. So when you are calling the model, you're using the real-time endpoint to call the model. And if you are going to structure it on a cloud platform, like the latency Jacob spoke about, you make it that, so that real-time endpoint make it that it answers you almost immediately. You get. So it's not really reliance on data engineering if you are talking about the ML part. Its reliance is on the MLOps engineer. That's part of real time. But we're going to talking about building a pipeline that takes from like a streaming platform, like a YouTube or something that's like Twitter now. If it's that kind of thing, like moving data from Twitter real time to like maybe a dashboard or a model or whatever it is, that's where data engineer will come into place. So they'll build the pipeline that will running consistently. So the tools they use to build like a batch pipeline is different from the ones they use to build a real-time pipeline. I don't know if Jacob touched that part or if probably maybe later he will touch that part. The tools are different. You get the way you configure it is different. I mean, is that maybe that your question is also pointing to? But if it's the aspect of the model itself answering real time, you talk about the way it is being deployed and the kind of endpoint you pick. Did we answer your question, Tochukwu? I just hope we're not
Yeah,
confusing you more.
yeah, I think this helps because like initially where the angle of my question was coming from was just at the intersection of data engineering and machine learning in
Okay.
relation to bioinformatics. You know, like maybe you can build a pipeline that would enable you to like kind of extract maybe any sequenced genome, and then from there you can do maybe prediction based studies
Okay.
to get insights. Yeah,
Yeah, so
like
yeah, it's the endpoints. Just if you can research on endpoints, I think Azure offers two types of endpoints, batch and real time. Just see how that relates to if it's the ML and data and that part. But if it's that there's already a platform existing that is streaming, yeah, and you want a data engineer to move data from that streaming, and you want it that as it's happening, it's coming into your side, and that's a different conversation.
okay, thank you very much.
You're welcome. Thank you,
Yeah.
Jay.
Yeah. Someone was talking about before my this thing went off. Someone was talking about Azure data fabric or so. Someone was asking that question.
Well,
Okay, let me sorry.
I think the question is about Microsoft Fabric. Okay, so
Yeah,
Shola,
yeah. So let me just well, I'm not a fan of Azure per se though, but let me just say this. So I think the most important thing about before we go to talking about technologies or infrastructures, basically like components, like what you use to implement those things, I think I would advise that you learn the basis, like the fundamentals of data pipeline itself. So those components, like I've mentioned, they extract, they transform, and load are actually very key. The tools you use later doesn't really matter. And those tools will be dependent on budgets from your stakeholders, basically. You get, so those things does not really matter. What matter is understanding how to transform this data to answer these business cases, how to look at data governance, look at data privacy, scalability, like I've mentioned. Those are the key components. Now, the Azure and the Google Cloud, AWS are just cloud platforms to implement these. You get, and in between, you still use Python and SQL, basically, which are actually very key, are very, very important. You understand? So I would say don't focus on the technologies first. Focus on Python, SQL, and the business needs, and how to address those business questions. And most times, these things are domain and specific. It means you also have to have a domain knowledge of how to answer these questions. I don't know if that answers that question, but I like Azure and Data Fabric is just it helps both data engineers and machine engineers to build, automate data pipeline end to end, basically. Yeah, just like you would have data. What's it called? Is it Azure? What was that one again? We discussed that time.
Which
Azure.
one? Endpoint or which one?
No, not
MS.
endpoint, for automating data factory.
Okay.
Yes.
Yeah.
They're just just trying to bring everything together under one umbrella. Just like Google BigQuery, you have GCP, like GCP. You have storage, GCS. You have BigQuery. You have Dataproc for running PySpark and all. So they're just like they also have what's it called, AWS. You have Snowflake. You have a lot of them like that. I think you have this for streaming. You have Databricks. You have the Confluent or so for streaming using Kafka. You understand? So those are just then. Pete was asking if I mentioned the type for streaming. So for streaming, you have different technologies like Kafka, AWS, Zcanis, they call it now. Different ones like that. For batch processing, there are the other ones too. I think you have Informatica or something. I can't remember the exact name for batch processing, for like ETL process itself. They also have like Fivetran, Airbytes, Stitches. Those are those like new technologies, like for modern data stack for creating data pipeline and ETL process, basically. You understand? Like I said, the technologies will come later, but the foundation itself is trying to understand how these things work, basically. You get. So if there's another question, I'll quickly just try to run you through one code. I know my time is almost up. Just run you through a code of a simple data pipeline, end-to-end, from extraction to loading to a database.
No, I think you can go ahead. I think if you have any other questions, then we'll just drop it on the chat or reach out to you.
Thank you very much. If I'm too fast, please don't fail to call my attention. So this is a script I prepared for this class. So I'm running it in Google Colab. So data pipeline, basically. So now I've put a few e-commerce data sets in a folder. This is I'm just trying to map my Google Drive to this Colab, then change to the directory where I have the CSV files. So I will just run this so that I can. I think it already mapped. Let me just confirm. Just try refresh and see if the errors. Okay, you can run that on your own. So what I initially did was to import change the drive location. Those are not needed. So I think when you're running your Python, your Pandas system script, Python script, without Jupyter Notebook or Google Colab. So ideally, what you do is to import your libraries. Yeah. Then ideally, what you do if you have like multiple CSV files, for instance, or different source, is to just load all the files like this. Ideally, that's what you do. And now, if you want to, what's it called? Look at informations that are available in this file or data, all the data points available in data. You would probably want to check the name for the columns, check the what's it called, the number of rows and columns, data types basically. Then when you do this, you means you have to repeat it again for the entire, for the three CSV files or the three pandas data frame. You get. So this way they'll say use like go the dry way. So don't repeat yourself. Because ideally, if I do this now, it means I have to do the same for the three data frames. So what we'll now do is to write, to write a function to extract those information, which is this. So this is, we're defining the function. The name of the function is extract data, which is the extraction phase of our data. Then I'm also trying to handle the error. Thus, in case it does not find that file, it shouldn't return an error. You understand? You just keep it like that, move. So these are just trying to print, check the size of the data, the parts, so this is the parts. This is the parts. So trying to check the parts of where it's coming from, the shape, and also the data types. Then I also view the data frame, for each particular data set that was imported. Then the function would, if there are no errors, just skip, except then it will return the results. Now, this result will just be a printout of all the informations that have been stated here. We'll print them out. Then if you notice now, this is just one function. Yeah, one function for this entire three data frames that I have here, or three parts. If I run them, it will run all the information. So I don't have to do them one after the other. You get. So this is software best practices, one of the software best practices you have to employ when building your data pipeline. And when that is done, you are done with this extraction phase. The next phase is the transformation phase. Transformation phase, which means you are now trying to aggregate, filter, clean, and all of those things. So now we also define a function. So at the end of this entire data pipeline, we'll bring all these things together, these different components, the extraction, the transformation, and the loading phase, into a single pipeline, which is like a pipeline itself. So these are those different components. So we can have like different script for this one. We'll now have a script that runs the entire, the other scripts, like all the scripts together, which will not be like the pipeline itself. So now we'll do like data quality checks. So we'll check if there are duplicates, it will drop it. We'll check if there are missing values for the numerical columns only. So that's what this function is doing. So we're just checking for, what's it called now? Missing values. Then take the average of that missing value and fill them of all the the values of that particular column and fill them, the average. Then we'll drop empty rows, like no values, we'll drop them, and the return. So now the same thing. So we'll call this function again now. So you know how function was basically in Python. I believe most of us here already start using Python. We are very familiar with Python. So this function now, we'll call this function to clean this entire data set. You could even decide to do like a for loop, sort of doing it like this. Maybe create a list of this data, this entire data frame, create a list. They run a function, inside this, write the for loop inside this to run, like inside the function to run or to read all the data frames, to clean them, sort of having these separate ones like that. But I'm just doing this for us to understand. So now if we run this, assuming we run this, you would see get the result that this thing has been cleaned. So this is under transformation too. Now we've done the cleaning, checking for duplicates and all of those things. Now we need to now aggregate our data. For us to aggregate our data, we also need to merge our data, because there are three different data sets. We're going to merge them because why? There's a business requirement that says they want the total price. And the total price can be found in the orders table and what's it called? Product table. So what I mean is sorry, I meant to say orders table and product table. So the price, you have the price in the orders table, and you have the what's it called? The quantity. Sorry, you have the price in the product table, and you have the quantity in the orders table. So now we'll have to merge these first two first to get so we can be able to compute for this total price. So we'll merge these two data sets first with their unique key, which the key they have in common, which will probably ideally say primary key. But if you are doing something like dimensional modeling, you have to now create surrogate key because this will now become natural keys. But that being said, we'll merge these two tables, that's the orders table and the products table, with their common, the key they have in common, or the column they have in common that has the same values from both data set, which is the products ID. So when that is done, we'll now aggregate. So this is where the aggregation comes in. So aggregate. So we're now saying we'll create a new column inside this set data frame, which is this. Then we'll now multiply. So now we're now trying to filter out this column, multiply by this column, price column and quantity column, which will now give us the what's it called? The total price, which is what we're trying to get for our stakeholders or the business owner. Then we'll now merge. So we need to know how much total price for each product. So we'll now merge it with the customer. So maybe we also want to know which customer, bought so and so for so and so total price for so and so quantity. So now say, okay, let us merge the customer data with the ones we already have, which is this product orders data frame. Do you understand? So when that is done, we merge. So now, one of the columns we've merged before previously has the customer ID. The customer ID. I think that should be the orders table or the orders data set here. That's the customer ID, which is a common column or key between the two the two tables or data sets, as the case may be. So when we merge them, then you also need to persist your data. So persist means to save. You understand? To save, just in case there's something goes wrong to the database or something, you have like a backup, to fall to. So that's why we're saving to CSV. To have that backup, you can always fall back to. Then we'll print the data sets. We want to confirm how many rows and columns are in data sets. So that's why we're now using index. You like your table now. So index you index the row is 0 and the columns column is 1, like that. So you're taking the first and the second, like that. So that being said, everything is also as the same. So trying to make sure that you handle the errors along the way. Then you call the function. When you call the function, it will not give you like a big table where you have all the information, 3 data sets merged as one. So we call the function. Now it's not time to load to database. For this database, I use DocDB. I use DocDB just like SQLite, but this one is more for analytical purposes because it has compute power. So I use DocDB. So what I do was to import the library, then create a database. This is how to create a database in DocDB for us to enable us to store the data. So I created a database, then I called it e-commerce.db. Then for me to load this thing again, I don't want to just load it like I will load it on a very good day. So I also wrote a function so I can have everything there, because ideally, what would have happened before is to like if you notice here now, I wrote this create function and this and create db. But also it's also here. So it means for every line of code, this white dry is important. For every line of code, it means I have to go to every row like create new cells to run particular code like that. But with function, you don't have to repeat yourself. You would just put everything inside the same function, and it will run perfectly well. So what I did now was this function, I just tested it. Okay, it's working. I brought it here again. This variable here, I created this DB connection. So since I tested it was working, I brought it here again. So this one will not run because I'm using this function. So I brought everything here. Then I also created a function that will contain the parameters, which is the database function. That's the data coming from this transformation, this final data now. That data frame. So that's this one. So this one, we're just writing a parameter that will load the name of database and the table name. Now, this is how you save to, just like you're saying, to CSV, to Packwet, and this is how you save to database. But the other ways you can also create like tables, schemas in database. But I'm just trying to keep it simple. You just save it like this, since it's just one table we are trying to save. Save it like this. So these are different parameters that you would have to impute. So if exists, so this is a connection, connecting the database, which is this one. Then if exists, so this one means like, so ideally if you're creating a database, using your SQL script, you do something like create table one if exists, something like that, not with table name, so something like that. So this one is saying if the table exists, replace the table. You understand? If it exists. Then the index has come from data frame. Ignore the index. Don't put the index. So that's number you have, I said. Don't include that one. You get. So when that is sorted, now I want to check if the records the record I was trying to confirm from here initially, if it's the same thing that's in database. So it's just a way of checking quality assurance, logging informations, trying to monitor logging and all of those things. So I want to also check if it will give me the same results I got at the end of the transformation phase, if that's what I'll get in database. So this is just a way to check if what is in database is what is in the transformation data frame, the final result. So I'm using the shape, so just checking inside if you are the same. So that's that. Now I will call this function and it will run. Sorry, I don't know what's happening. I don't want to start debugging. It'll take it off a lot of time. So I'll share this script and the data set. You can go and run it. Because also use it we'll also use it while we're doing the Airflow class for next week. We'll use this Python code. We'll see how to automate it in using Airflow. So now we want to run the entire pipeline. So ideally, we'll also import our Python packages. Then we'll now have like a function that will run all the other functions. You understand? So like the main function that will run all the other functions. Now we'll now have 3 steps involved. That's the 3 phase of data pipeline, which is extract, transform, load. Now you see this function. These are the functions we have before the extract data function. So now we're just putting all the paths to the files here. So when that is done, we'll just now put these variables now inside the clean data function to clean it. It will clean the data. You understand? So you don't have to run each line of code. It will just run everything at once. So to do them stage by stage like that. Then we could also do this in Airflow. You can run them in parallel instead of doing it one by one like that. You get. So we'll also look at those later, much later. In parallel, even the same thing, run them in parallel, so you don't have to run them one after the other in parallel. So yeah, that being said, so when that is done, it will now merge the data. So you see now, so the output from here becomes the input for this one. The output for this becomes the input here. You understand? So when that is done, we'll now load to the database, which are DocDB. So I decided to name this. So those are the variables we had used, the parameters we had used for our function to load to our database. So you see the final data frame, which is this one. This is it. Then we have what's it called now? Our database name, which is this. Then we now have the table name. So we said, okay, since we want to know the total price for so and so and so, let's just have this as the table, the name of the table, total price for this table. When that is done, it will return this data frame. You understand? Then it also return the number of records that it has on the data frame. You understand? So once you run this script, it would run from extraction to transformation, then lastly to loading data to database. So that is it. Thank you very much for the opportunity. I don't know if you have any question regarding this. Like I said, I would share the scripts with Onyeka so you can share with you guys.
Thank you so much, Jacob. Thank you. Even myself, I've learned a lot from all of this. How the coding aspect.
Both like you.
Oh God, oh Lord. There's always going to be something, a new way to just jump in. So any questions from the house? Anything? Oh yes, please go ahead, Emmanuel.
So my question is, after doing all this, how do you present your data? I have a bit of challenge with that.
How do you present your data? In what sense?
In the sense of, you see, once you extract the data, you analyze everything. How do you present your data? Let's say you want to present it to someone without showing the person how you did it through the codes, like in a graphical information.
Okay, so are you saying in terms of analytics or?
Yes, please.
Okay, so that is the work of the data analyst. So So I know in some organization companies, especially in startups, you have to wear many hats, like you being data engineer, ML engineer, data analysts, and whatnot. So it's just basically there are ways to do that. You could use PowerPoints like slides, like getting the key findings, just like this slide I had initially. To just getting the key findings. So the point of having data pipeline is to get that information stored somewhere, which is data warehouse. So you can now use that report ready data sets to now start digging into insights and all of those. Then you could also have like interactive dashboards. You could do that with Holistics, Metabase, Tableau, Power BI, and whatnot. You could also just create an interactive dashboard. You can also use as a means of presentation to your stakeholders or whoever you're presenting to. I don't answer your question. Anyone can also add to that if you have.
Yes, it does. It does. Thank you.